Exact values in trigonometry. We use exact values in trigonometry so that the answers are more correct, and there are two triangles that we use to determine these exact values. The first triangle I'm going to show you comes from our unit circle. So in the unit circle, we know that if this is the origin, then the radius of this circle is 1 unit. So I'm going to draw a right angle triangle in here, like so. I know that this has a side length of 1 unit and this has a side length of 1 unit because both sides are the radius of the circle. Since these sides are the same, this is an isosceles triangle and the angles must therefore be the same. And these angles have a value of 45 degrees since the third angle in this triangle is 90 and all angles must add up to 180 degrees. We can use Pythagoras' theorem to determine this other side. So c squared equals a squared plus b squared, which is going to be 1 squared plus 1 squared. So c is going to equal the square root of 2. That's going to be this value here. I'm going to redraw this triangle a little bit clearer here for you to see. So we have the square root of 2, 1, 1, 45, and 45. And we can use this to determine some of the angles, some of the exact values of trig functions. So using this 45 degrees, let's look at sine of 45. It doesn't really matter which one we use here, but I'm just going to use this one. So we've got the opposite side, hypotenuse, and adjacent. So sine equals opposite over hypotenuse, which is going to be 1 over the square root of 2. Now, we don't really like to have surds down the bottom, so we're going to multiply this by the square root of 2 over the square root of 2, and that's going to equal the square root of 2 over 2. And this is our exact value for sine 45. Cos 45, you'll see, will actually turn out to be the same value. So cos 45 equals adjacent over hypotenuse, which is going to be 1 over the square root of 2, which is the same as what we have up here. So I'm going to simplify this one again to the square root of 2 over the square root of 2. Tan 45 is going to be opposite over adjacent, 1 over 1, which is just 1. So we now have 3 exact values for trig functions with an angle of 45. We also know from our unit circle some exact values for 90 degrees. So 90 degrees is going to be up here. And since the sine of our unit circle is equal to the y value, sine of 90 degrees is going to be equal to 1. Cos of 90 degrees is going to be equal to 0. And we know that anything divided by 0 is undefined. So tan of 90 degrees is going to be undefined. So I'll go UD here for undefined. Let's have a look at another triangle that we can use for exact values. If you were to type into your calculator sine of 30, you will get a value of 1/2. We can use this to form a new triangle. So here is a right angle triangle with the 30 degrees. And since sine functions equal opposite over hypotenuse, 1 over 2 for 1/2. We can then use Pythagoras to determine the value of this side. So c squared equals a squared minus b squared. We're going to end up with 2 squared equals that should be plus, squared plus b squared. Rearranging this, we're going to get b equals the square root of 3 for this value here. We can also find out what this angle is by going 180 minus 90 minus 30, since all angles in a triangle must add up to 180. So this is going to be 60 degrees. Using all this information, we can find exact values for 30 degrees and for 60 degrees. So let's start with 30. So sine of 30, we know, is 1/2. Cos of 30 is adjacent over hypotenuse, so the square root of 3 over 2. And tan of 30 is equal to opposite over adjacent, so 1 over the square root of 3. I'll just change color. Let's now do 60. So sine of 60 is opposite over hypotenuse, so square root of 3 over 2. Cos of 60 is adjacent over hypotenuse, so 1/2. And tan of 60 is opposite over adjacent, which is just the square root of 3. So here is a summary of all that information I've just shown to you. We have exact values for 30 degrees, 45 degrees, 60 degrees, 90 degrees, and of course 0 degrees. And these are the two exact value triangles that we use to determine these values. Let's have a go at a couple of examples. Find the exact value of each of the following, starting with cos of 60. So using our triangle from the previous example, we've got 30, 60, 90, 1, 2, square root of 3. Cos of 60 is going to be adjacent, from here, adjacent over hypotenuse, so 1/2. Now let's have a look at this one. This one is going to be a value that we need to use the 4 quadrants for. So we've got our 4 quadrants here, 0, 90, 180, 270, and 150 is going to sit somewhere in this second quadrant. And to determine values for this, we're going to use 180 minus theta. So 180 minus 150 will give us 30 degrees. And we can find, using this, that the sine of 30 is 1/2. That's the exact value here. And now let's just check if that needs to be a negative or a positive. So we'll use all stations to civic. Sine is positive here, so therefore we can write the sine of 150 degrees is equal to 1/2. And one last example. Again, we're going to need our 4 quadrants here, and 135 is going to sit in this second quadrant again. So I'm going to use 180 minus theta. So 180 minus 135, which will equal 45. So using our first exact value triangle, tan of 45 is equal to 1. And we need to check whether this is a negative or positive. So all stations to civic. In this quadrant, tan is negative. So tan of 135 degrees is equal to -1.